Hi, welcome to the lecture on Chapter 3. We'll look at exploring the Linux file systems. So we're going to look at how do I understand what the file systems are, how to navigate them, how to get around them. Of course, this is all from the command line interface. You all know how to get around the GUI and bring up a file list and click on a file, click on a directory, open a file. The question is a little bit different from a command line, so we're going to talk about that from a command line percentage. We'll also look at the structure, how to know if a file name is a relative path name or an absolute path name. We'll look at various types of different files, look at the file names, the types of files, any kind of wildcards that can be used to help manipulate or be able to look at, search, copy multiple files at a time, look at ways of exploring the contents of text and binary files. And then there's some commands to actually search text files with certain expressions, and we'll use a command called grep. We'll look at a command line editor called the VI editor to help you manipulate text files. And then some different common alternatives to that VI editor. Not that I don't think I'm going to assign you anything with those, but just know that they exist because you'll probably see something on the exam. So let's look at the Linux directory structure. A directory is just a section in memory to allow use to organize files into some kind of logical structure. It's stored in a file system in a particular partition, hard disk, something. Now, you've got an absolute path name is actually the full path name from the root of the machine all the way to its current directory and file. Now, the term root is basically the top level, as low as you can go or as high as you can go in a tree structure. If you think about an inverted tree, the root is basically the root of the tree. You can't go any further. How do I specify root? It's specialized with the slash. You see that / there? That is that. And then all the files and stuff underneath it form some kind of hierarchical tree, like a maybe you're looking for a matrix management structure of a company. CEO on top, vice presidents, directors, employees, and you see that structure underneath everything. So the way Windows does it, you see C:, something that you're kind of used to. Linux, it's definitely better to picture it as an inverted tree. So you see the root at top with the \, and then underneath it are different subdirectories, home, Windows, whatever the case may be. So you just get a picture between the two. Just think of an inverted tree for that Linux directory structure. Now, when you first bring up when you log in as your login and password, as long as you don't log in as root, if you log in as your special user, you're going to get put into your home directory. It's a unique directory just for your user account. If you want to get back or refer to your home directory in a command, you can use the meta character, that tilde right here. That can be used to refer to your home directory. Now, if you want to know where you're at, there's a command called print working directory, pwd, and that displays the current directory of where you are in this tree. Now, if I want to change to a different directory, I use the cd command or change directory command to be able to change that directory. And of course, the argument that you're specifying is, what am I changing to? Now, you're in your home directory and you want to change directory. The question is, where am I changing to? Now, I can change to a fully qualified path name, which has to specify root all the way down, or I can specify a relative path name. It's relative from where you are currently located, from your current working directory. So if you're at your home directory and you wanted to change to a directory, you want to make sure you do specify the parent directory. Now, if you want to go to the parent directory, the parent above you, now think this is an inverted tree. So you want to go one step closer to the root. To get there, it is ... will get you one directory back. Now, if you wanted to go 2 directories back, you can go ... / ... which gets you 2 directories back. Go up 2 directories. Now, of course, just to keep terms straight, a subdirectory is a directory that's residing underneath another directory. Linux offers a tab completion, so you start typing a command or a path and you hit the tab, it'll complete it. Now, you got to make sure you type enough characters to make sure it is a unique command, because it'll still, if there's multiple files or something that has the same 3 characters when you hit the tab after the second one, it may go, still don't know which one you want to go to. So you got to be specific enough to know that it's a unique file directory. Now, the point of directory structure is basically just to organize files into an easy-to-use format. Now, you could take every file you ever created, put it at your home directory, and then hunt and peck to find which one you're looking for. Or you can organize them in a way that makes sense, whether it's by class, whether it's by date, month, whatever you want. But I think it'd be easier to look for all your math homework in your math folder, your Linux homework in your Linux folder, your English in your English folder. You do it when you've got a filing system at home or a filing cabinet. The same thing happens here. This subdirectory allows me to organize my data. Now, there's also ways, so how do I view data? How do I see it? We'll take a look at that. Now, the types of files that Linux has is you've got text files, which basically what? They're just stored information in readable format. You can have binary data files, which stores programs that are related to executables. You got the executable files themselves, and you've got directory folders, and they're just serve as placeholders to organize other files. You've got linked files. Maybe they're associated with one another. Maybe you're putting multiple files together in a program. There are special device folders, which represent devices of the system, hard drives, serial ports, printers. There are named pipe files, and we'll talk more about pipes later, but they're basically identified information to identify a channel, a hardware channel that passes information between processes. Socket files allows a process to one computer to write to a local file. It's kind of similar to a pipe file, but just think of I'm just sending data from one process to another, or one program to another. Now, when you create a file name, you can have them up to 255 characters. Rarely are they longer than 20, because most of us can't type. I can't type that well, so I'm not going to make it very long. But I want to make sure the file name is understandable enough that I know what I'm looking for. You can use alphanumeric characters, underscores, dashes, and periods. Now, you can put a file extension on it, and that's all the characters after the period. And that just denotes the type of file. And most Linux files do not have file extensions. Whereas in your Windows operating system, you have pretty much an extension on every single file. Now, here are some common file name extension. I'm going to go through all of them. But you've got, C, C++, HTML, text files, object files. So just know that there are several others, JPEG, so shell scripts. We'll get into those a little bit later. Now, if I have this whole thing in this directory structure, the question is, how do I know what's in my directory? Because like I said, we're not working at a GUI level where you just click on the directory and everything appears. We're sitting in command line, so you're kind of saying, okay, well, what command do I have to execute? Well, the command, and what do I do? I want to list my files. I want to see the list. The ls is the list command. So, and then you're going to pass an argument that bases on what you want to be displayed. The -F, capital F, is argument to view list of files and their type. The -L gives you a long list so it provides a whole lot more information about it. You'll probably use the ls-l command a lot to get information on it. Now, the type of information that long listing just lays out, it gives the file type in a character format, gives you the permissions, otherwise security or called mode of that file. So you can make it read, write, execute by different types of people, the world, group, or others. So gives you the list of permissions. Now, it could give you a hard link count if there's any links to this file. The owner of the file. Is there a group owner that has it? Of course, what is its file size? What's its modification? When was it modified last? And of course, what's it called? Now, the file command can display the type of any file. Now, arguments indicate, what file or files to analyze, identifies the difference between the different types. Now, you can also hide files. Now, of course, when you're doing an ls or an ls-l, there's some commands that you really don't care to see. You can hide them from your normal viewing part. And all those hidden files start with a dot, a period. So then if you do an ls-l, you don't see those hidden files. But if you want to see the hidden files, then it's an ls-a, maybe an al, or in this case, give you an example of ls- space -a, capital F, to see the files and the file type. So here's some of the options that you can use. Most of the ones I've used the most of ends up being probably the ls-l. Or maybe the ls-al. So you can put a couple together to go through. So just some common ones listening to. Here's quite a few others. You can reverse the sort. You can give me a list recursively through all the subdirectories and show you lists. I think some of the labs will probably get a chance to give you some sort options and stuff. But a lot of these are special cases that just know that they exist. That's really all you really want to worry about. Now, typing file names is long, and sometimes you want to have some shortcuts put into place. And in this case, you can use wildcard characters. They're characters that can specify matching multiple files just by putting a single character in. Can use in most of the different file systems. Some of the wildcard meta characters are an asterisk, matches 0 or more characters or file names. So if I was looking for everything that began with MA, so I would do ls-l space colon or asterisk M or MA asterisk, and it would just list the ones that started with MA and then matched every other character. That's one I use the most. Sometimes there's just one character that's maybe different. You can use a question mark, and then you can just do stuff that begins with AE, anything that begins with certain characters, and then just put them in brackets and begins that way. So just different options here, but like the one I use probably 99% of the time would be the asterisk. Now, there are ways of displaying contents of text files. You can use what we call the concatenation command, cat, C-A-T command, and it displays the contents of that file. If you do a cat-n option, it would give you a line number. So based on what you're trying to do, you may want to, have a line number. Okay, I'm looking for the 15th element in this file. Putting the -n option allows you to get that. If you have a log file that's recording processes going on, sometimes you say, gee, I don't want to see the first one that executed, I want to see the last ones. In this case, you can do the TAC command, and it displays the contents in reverse order. So for a log file case, it would be very nice to see what are the newest entries, not the oldest. So it just makes a little bit easier. So it's a TAC command. Now, if you want to get only the first 10 lines of the file, you can use the head command. The last 10 lines, tail command. Now you can, granted, they include blank lines. Now, if you only want to know the top 2 lines, you can put a -2 or a -3 for the top 3 lines. So you can tell them just how many, but as a default, it's 10. But if you want to go longer, shorter, you can do that. Now, for large files, you don't want to use the cat command because it just scrolls through everything, and everything won't fit on the page. But if you use the more command, it displays a text file page by page, and then by hitting the space bar, you get the next page. If you enter the enter command key, you just get one line at a time. So it just kind of tells you how much of theirs. If you want to use the less command, it's like the more, but it allows you to use the cursor to scroll up and down. So I'm sure we'll get to play with some of those this semester. Now, sometimes users can use keyboard shortcuts to interact. I'm not a big keyboard shortcut person. There's people out here that live by them. But you can type in less, so you can type in H to get you the help screen, Q to get you the Q. So there are some shortcuts, and when you look at the manual pages for those, you can tell what shortcuts there are. Now, more and less commands can be used. You can string them together. So in this case, if I know I've got a very large directory, I can say ls-l, and here's this. I talked a little bit. We were going to see about pipe. This vertical bar is what we're going to call a pipe. It's a meta character, and basically, I'm going to stream the output of the ls-l, the ls-l into the more command. So it's going to pipe this in. The more commands is going to display one page. You hit the space bar, go to the second page. So I can string these things together, and we'll use that in a lot of script files. So get comfortable with that. Now, what happens if I want to display contents of the binary file? Now, granted, normally you'd use the program that created it. But if you're searching for information inside a display, you can use the strings command to search for and display the text characters in a binary. So it just kind of gives you a way of searching for that text file. And it may tell you what this binary file is used for based on what kind it is. The OD command gives you the octal binary, so base 8 for you math majors. or you can use the OD command -X option for the hex format of the file. Becomes beneficial if you're troubleshooting a program. Searching with text files, within files, there's several out there, but they're basically text tools are used. The commands are used to search for and manipulate text, maybe database information and stuff. They're called regular expression, text wildcards that can search for specific text. And basically what they do is match patterns of text within a text document, and they're used by several different programs out there. grep, Emacs, C++, Perl, many more allow these text tools, these regular expressions to be searched for. We're going to focus on grep. You're going to be exposed a little bit to Emacs, but I don't think I'm going to give you any homework in Emacs, but it's just an editor that allows you to create text files. Now, these regular expressions, they're different wildcards. These wildcards, wildcard meta-characters that we just talked about, are interpreted by the shell. So they're looking for files. They're looking for matches in files. Where regular expressions are interpreted by text tools, so I'm looking for things inside text files. So typically they'll have different definitions between wildcard and regular expressions. So just know that they're different. Now, regular expressions are basically divided into two different categories. There's common regular expressions, used for most, and then extended regular expressions. So they're less common and available only to certain tools. Here's some regular expression, and here you get your asterisk, regular, plus sign, periods. So you get different columns. So, and you can tell the different types, common, extended, more of the ones we're going to probably play with. And one of the homework assignments, or at least in the labs, are going to let you to play with some of the regular expressions with the grep tool. Now, that grep command, it's a global regular expression print, is the breakdown of that name. It basically displays line in a text file that matches your regular expression search command. Now, egrep displays in a text file that matches extended regular expressions. You can get it through the -E option. And then fgrep does not interpret any regular expressions. It's definitely a whole lot faster than egrep, and you can get to it by grep with capital F. But I think we're going to play more with grep just so you get used to the regular expression searching. Now, basically, it requires two arguments. One, the text string you're searching for, the regular expressions, and the file or files that you're willing to search for. Now, keep in mind, grep is a case sensitive. So, if you're searching for something that you want to make sure it's insensitive to upper or lowercase, use the -i option. Now, it matches the pattern of text, and it ignores division into words. So you want to make sure that if you're searching for occurrences of a word, you want to make sure you surround it with quotes, something of that nature, so you make sure just get that match. Most common editors that we use for text editing, most of them systems have programs that do there. Most Linux distributions come with several different options. One's command line based and one is usually GUI based. The oldest and probably most popular text editors of the old Unix operating system is the VI editor. I think it stood for Visual Editor. Now Linux has an equivalent VIM. Advantage is it's portable. It's on most Linux distribution. You can port it between Unix and Linux. The VI editors supports regular expression, you can pour, it says over 1,000 different combinations, functions for each user. Now, keep in mind, VI editor is called a bimodal editor, 2 possible modes. There's a command mode, which performs text editing not related to inserting text, such as deleting text copies, saving changes, or the insert mode. So you got a command mode or insert mode. Insert mode does nothing but put information into a file, and then if you hit escape, it goes back to the command mode. So when you first come up, you're in command mode, and then once you want to start adding text, you'll see the insert mode. Now, the user environment's customizable. I must talk for a living. Now, through this, and when you can alter these settings if you use the colon. If you hit the colon at the prompt, you can see that. Now, here are some common keyboard to insert information. Here it's going to insert, at the places the current, the cursor is. I've got the append, which says, hey, I'm going to insert mode in places after. So I got insert, says I'm going to put a cursor before, places the cursor before, places the cursor after, opens a new line, insert mode opens a new line underneath, capital I places the cursor at the beginning of the current line, A appends to the end of the line. So different options. So like I said, keep in mind which way you want to go with it, which command you're going to execute, and escape gets you back to the command line prompt. Other key combinations that are commonly used, W moves the cursor one word forward to the beginning of the next word. E gives you the end of the next word. Back, the B gives you back one word. Here you go, and they give you example. 53G moves the cursor to line 53. G is, capital G says the cursor to the last line of the document. So several different options as you're going through these. I'm deleting the whole line. I'm deleting one word. I'm deleting 3 words starting from the character and the cursor on. So you get a lot of different options that you can play with. Copies one word, writes, this copies the current line. So it's like a Control C in Windows. So you can get YY to do this, and then if I want to place it, here this I'm copying 3 lines. But if I want to paste, what do you think I got to put in? I got to do P. So P, so that's your paste command. But it copies it, underneath the current line, capital P above the current line. So different options for this. I can do a slash to search. I can $sign to search, or a question mark to search for the first occurrence. The lab will give you some chances to play with the VI editor and do some things modifying a file. :Q says I'm going to quit the editor, but no changes. The :Q with an asterisk there says quit and does not save. So I'm getting out totally. Well, guess what? If I want to get out and save, I do :W. So I'm writing the file, and then I'm going to quit. I can save it to some other name. So this is like the save as. So :W, and the file places it, the current document in the file that's there. If I want to escape to execute something, escape the VI editor and let the shell respond, you just go ahead and put the, lost my cursor here. You put the asterisk in front of this, so this would execute the date command. This would actually read the output from that bash date command, and then it puts it into the document underneath the current line. The :R says, hey, give me this file name, and inserts that contents in. The different set commands and how to set all the variable environmental settings. If I want to search for the /s/ search for that, but in this case I'm going to substitute any place that has lowercase the with capital The, and I'm going to globally do it. So I'm going to do it everywhere in the file. Now, if I want to be specified as the range that I want to make this change to, I can do, from line 1 to the end of the document. That works. Make that substitution. So you can put key combinations together at the command prompt mode. Now, other common text editors is GNU Emacs. It's comparable function. If you want to install it, the yum install Emacs command, and then to open a file, you just specify Emacs in the project. Now, Emacs editor uses control key combinations to form a lot of special functions. It may not be as easy to use. Of course, after going through VI, you're going, oh my gosh, that's not very easy either. But Emacs has a lot of memorizing of control character combinations that I never really liked. So just something to keep in mind. So here's some examples, some of the keyword, Control A, Control E, moves cursors around. Gives you a rough idea of a graphical session. Now, it gives you a lot more benefits looking at common text files, but you got to keep in mind you got to use the control characters to do it. Some other common text editors, Nano Editor, very basic, easy to use, used by Linux administrators with advanced function when you don't need all that advanced functions. So, of course, the combinations are listed at the bottom of the screen, makes it easier. If you want to install it, use the command yum install nano. Gedit editor, it's a graphical text editor, functional in GUI environments. Again, doesn't have a lot of the advanced functionality like Emacs or VI, but it's easiest editor to use. Maybe it's analogous to WordPad or Notepad. It gives you a rough idea how it looks. So hopefully this chapter gives you a little bit of idea of the file systems, what types of directories and files, how to move around them, what types of files are stored in Linux, how to display the files with the ls command, a little idea about the meta characters, special characters to do special functions, different types of how files can be viewed with the head, tail, cat. So regular expressions using grep, searching for certain text patterns, how to use command line text editors, VI. So hopefully that gives you a little bit to help, and we'll go through there. See you in class.